Hello everyone. This is really a jam-packed conference and really exciting stuff going on. Microservices, GitHub Actions, intelligent bots, Xamarin. I hope all of you are enjoying this. I'm really looking forward to the rest of the event. For now, we are here to talk about how to automate your network security for your Azure Functions. So just to be clear, my screen are on this side and my camera is here, so I will be looking away while presenting from time to time. I do know you guys are here, so I'll probably come back time to time as well. So yeah, let's start. First, a bit about me. So my name is Dushyant Priyadarshee. I work as a platform engineer for a company called New Day in London. And here's my Twitter ID, so Twitter handle. Feel free to follow me, follow up after this event with your feedbacks, questions, suggestions, anything. Everything's welcome. I also have a link to my blog post, so anything I say or present today will probably be on that website. So if you need, I'll post more links as well later on, so feel free to follow it up. From a software perspective, I have roughly 10 plus years of software development, mostly Microsoft technologies, and I think the last few years maybe heavily Azure based. I have done a bit of different programming as well. Began a long time ago with Java and then moved to Microsoft .NET technologies and did a bit of COBOL as well. But I think Azure C# .NET, that's essentially where I am right now. Who we are, New Day. So this is the company I work for. So we are a credit cards company or a financial company dealing with credit cards, and like you can see on the slides, we have a host of retail partners that we work with. The big names I'm sure you can recognize, like Amazon, Argos, and House of Fraser, for example, or Debenhams. So those are the big names we work with. We work only in the UK at the moment. We do have our own offerings like Aqua, Opus, Fluid, and Marbles. Those are our own credit cards from New Day Cards itself. One of the aims of New Day as a company is to help people be better with their credit. And we also want to responsibly say yes to more and more customers, and ideally more customers than our competitors and other lenders. So following up with that, let's have a look at the New Day platform. The technology upon which New Day is built, New Day software is built on. So we are heavily based on Azure services. So we leverage at least 30, maybe a lot more, 30 plus Azure services. And so essentially the software we provide has got integration of so many services on a public cloud. And on top of that, PCI DSS, I don't know if all of you are aware of PCI DSS. So this is payment card industry data security standard. And this is information security standard for organizations that deal or handle credit cards from major credit card schemes like MasterCard, Visa, others. So we need to be PCI DSS compliant. So if you think about it, we have a serverless architecture, microservices architecture with lots of moving parts, lots of different services working together, all of these in a public cloud, which currently is mostly in Europe data centers, but it is public cloud. So that, I hope, emphasizes how much security is a big part of everything that we provide. We are really serious about it. We need to take steps to make sure we are providing highly secured software. And that's where the platform team comes in. So the platform team I'm part of is responsible for the software platform, and it's the resiliency, the security among are the major things among different other parameters. And with the help of multiple other teams we work with, the development teams, the security team, the testing team, we try to adopt, and we have adopted in many places, the best practices, the industry best practices of CI/CD, automation, testing, many other things around software development. So I hope this sets the scene of where I'm going, is that security is quite important in the field that we are in. And I'm sure in many other software sectors that you would probably be in, maybe not only finance, maybe you're in medical devices, maybe you are in a e-commerce, which is similar to finance, but you would still understand that security is very important. So on that note, let's start with this discussion around Azure Functions. First, to understand who can access and trigger your Azure Functions and how do you restrict it. There are multiple ways. Obviously, you probably already know about authentication or authorization, where you can only say your Azure AD logged in credentials or service principal can trigger Azure function. So that's one way of doing it. Also, Azure front door. You can restrict what comes to your Azure function, app gateways, also API management. VNet integration is a good one because then you have your own private IP and becomes highly restricted as to who can access it. To be honest, it's network access, the third point on the slide. It's complementary with the rest. Even if we have authentication, we have Azure front door, we would still need network restriction access, network access restriction, apologies. So this is what we will be mainly talking about now, is how the network access restriction rules apply to Azure Functions and how they behave after the application of those rules. I will go into a bit more detail soon so that hopefully it's easier to understand. So first of all, if you think about why access restriction, why do we apply that network restriction? If you think this matrix of multiple function plans, consumption plan, which is essentially the cheapest plan, and we do use it a lot, at least in the development phase, if not going forwards. That's where we can already have IP-based restriction and private side access. So that makes it very important that we do have network restrictions in place from the beginning. Like let's say when we are deploying just for development purpose or testing purpose, we have this in place so that in production, we have restriction already set up for you and you have tested in a restricted environment. So that hopefully says that cost-wise, it also makes sense to have access restrictions for network sources. This is so now I can do a quick demo to show what I'm talking about. Hopefully it will make more sense. Unless you're already working in this area, it may not be meaningful straight away to understand what I'm talking about. So for functions, I already have deployed a few functions. This. So in my resource, let's go here. Where's it go? So I'm just looking for my resource group, network restriction. So I have already deployed multiple functions. So let's just open up this function. So just before the talk, what I did was I have got a script, which I'll share the link to the script as well. So this is a simple script, simple Azure CLI script, which just goes around, deploys 10 functions. And that's all I've done. So that in this resource group, which is taking a few moments to load, I've deployed multiple functions. One of them is this one, resource ID 12. And if I go to the URL, like you can see, I can access the function. I do have access to the function, meaning I can go ahead and trigger it. But at the same time, on the left panel, if I scroll down to networking and access restrictions, and I add a rule, and this rule, let's call it allow only this, let's say that priority is say 100. So lower the priority number, higher the priority. So lower the number, higher the priority. And here we need to give an IP address. So say an IP address is 145.56.12.13. And this has to have CIDI format. It doesn't have to, but ideally you should do, so that you can give a range. And in this case, /32 means only this IP, there is no other range. And if I add that rule, what this means is this function, the resource ID 12, can only be accessed from an IP source of this. Meaning now, if I go back to the same URL, it is forbidden, so I don't have access anymore. And that is because my IP, what is my IP? Let's see. Obviously, my IP is very different to what we added in here in the network restriction, which is 14556, and mine is 88109. So what I'm trying to show here is this is an easy way of restricting who can access your function. So if you have a company with network, you can restrict only to that network or a range of IPs in those networks. Essentially, the idea of the least privilege. Do not give access to everyone if they all don't need access to your function. So let's go back to the slide. So this was just a simple demo to explain what I'm talking about. Going forwards, if you think about an ecosystem, say we have many functions in our environment. So let's say we have function A, and we have two internal systems, maybe testing systems or whatever, they need access to the function. So this function needs to add these IPs in its network restriction set, saying allow these IPs in. What happens when a new function comes in? And say function B now needs to trigger function A, but the IP of function B is not present in function A. So function A hasn't allowed function B yet. So what that means is that this will be restricted because obviously function A does not know about the IP of function B. That is one issue. That's one issue we know about. Once we start using network restrictions, this is going to happen. And then you add scaling to it. This is straight from Microsoft documentation here. So essentially, the IPs, outbound IPs of a function are a range. They're not a single function, especially if you are using consumption plan. And to some extent, Microsoft has actually recommended that if you are using network restrictions, go ahead and allow list all IPs in the data center. But being a little bit of concerned about security, quite concerned about security, we would not want to do that. But that's one way to do it. If you if you are not keen on being in a highly secure environment, then that's one way to do it as well. But the scaling bit, let me explain it a bit properly. So let's say we already have function A, which has the IPs of the internal systems already allow listed, and we have also allow listed function B here as well. But say the request to your function B has increased a lot and lots of triggers are coming in. So you decide to scale up or scale out. What that means, the IP of function B has now changed, or probably has changed, and that could possibly cause a restriction issue. And function B can no more trigger function A. And that is again another problem spinning out of your network restriction rules that you apply. So think of a very simple solution to this issue. So one is when a function is created, we want it to be allow listed. And when a function is scaled, app service plan is scaled, then the function needs to be allow listed as well, or the IPs need to be updated. So solution would be, we have a function A, existing function A, and it's got the internal systems ready, already allow listed in it. And let's say we have a new function B. When B comes in, it needs to be triggered by internal systems. So we allow list internal system IPs in function B, and say we also allow list function B in function A, and the other way around. So it's a very simple solution. It's not intelligent enough to go in and check what is the dependency chain, who is dependent on what. It just goes ahead and allow lists whatever it sees in the ecosystem. So when function C comes, obviously function A now sees function C, function C says allows A, and vice versa. The same happens between B and C, and obviously the internal system needs to trigger function C. This is a very simple solution. So think about it in terms of, say you have a class with few public methods, so public only methods, meaning they all can call each other and others can call them as well. In in this case. Our public probably is not the right one, maybe internal, because then it's only being called within your ecosystem or your DLL in case of code. So with this solution in mind, let's also consider, which we also touched a bit in the previous slide, is that all these functions will have a range of IPs. They won't have a single IP. So each function, you are actually having IPs which may be shared with another company, another user, another consumer of Azure, which is again why this restriction is very important. With that in mind, let's go ahead and see what do we need. So we obviously need a system which can allow list IPs, which can do the heavy lifting, understand what to do and do it. We will need some system to tell this allow IP system to say, okay, this is the time a function has been added, go ahead and do it. A app service plan has been scaled, go ahead and do your allow listing service plan or service work. And also it needs to know what to allow. How does it know what are the IPs? It needs to figure out what are the resources, what are the IPs, are these IP ranges? So it needs to figure those out and then allow. And finally, it needs to have some kind of mechanism to go ahead and change your resource config in Azure. I hope all of you are following. It does get quite complicated. And if you have any ideas of how or what are these services, feel free to comment in the chat. Maybe we have selected the right one, maybe you select the wrong one. We'll find out. So the selected technologies at New Day, here we agreed that these are the three key technologies that we need. Azure Event Grid to tell us when a function has been scaled, a function has been created. Azure Resource Graph to give us more information as to what are the resource IDs, what are the IPs. And Azure Function is the main part of it, which is doing the heavy work, like get all the information together and apply the changes to the app config. Before we go into a bit more demos, I want to go into a bit more theory here about Azure Event Grid. If you have come across Event Grid before, this would probably be easier for you to understand, but many of you may not have, so that's why I'm going to explain a bit what Azure Event Grid is. Azure Event Grid is a service from Microsoft, Microsoft Azure, where it handles events from multiple sources. So the things, the boxes on the left, or the text boxes on the left, are event sources. So that's where the events are coming from. But then this bit here, this curly brace here, is called a topic. And say sports, for example, is a topic. Then all the events in sports come to this topic. In the same way, all the events in a certain source come to specific topics here. So for example, say Azure subscription is your event source. So the whole of your Azure subscription is event source. And any event in that subscription will go to that Azure subscription topic or Event Grid system topic for Azure subscription. But going forward, you may want to, like using the same analogy like sports and subscription topic, say you want to know about only cricket as a sport. In that case, that's your subscription. So you are filtering the topic of sports down to cricket, meaning that's your subscription. In the same manner, say as your subscription, so it gets confusing. Azure subscription, talking about Azure subscription, and the next one is Event Grid subscription, which is here. So Azure subscription events come to the topic, and then we filter it here in the subscription saying, no, we want only web app changes, or we want only app service plan changes. We can also filter it down to more, saying what operations we want to filter it to. Is it a creation? Is it a deletion? Or is it a scaling up, scaling down? So all these filtering we can do in subscription level. Final bit that comes at the end are the handlers. So these are event handlers. So whenever Azure Event Grid triggers an event or adds it to the topic, it goes to the subscription. Subscription here has to say, okay, once I've got my event, I want to pass it to a event handler. And that event handler could be a function. So you get, say, something has happened and the Azure function gets triggered. In the same way, Azure automation can be triggered, or your webhooks can receive your REST calls from Azure Event Grid. So that's a bit about Azure Event Grid. Now we'll go a little bit into demos. The scripts that I was showing you earlier, I've written another small script which just deploys an Azure Event Grid. Let me just trigger the script and then I can explain a bit. So if you see a simple script here, I hope it's big enough for everyone to see. It's a simple Azure CLI script. All this is doing is getting a topic name and in a resource group goes ahead and creates an Azure Grid system topic. In case I missed that, the thing that you probably have noticed here, that all these things, all these sources, blob storage, resource group, Azure Event, Azure subscription, and event hubs, all of them are Azure's own resources or services. So all these are all these will submit events to a system topic. It's only when you create custom topics you submit to your own custom topics. So that's why this run here is creating a system topic, because we want to look at the Azure system, in this case the Azure subscription, and that's what it's saying here. It's saying we want all events in this source. So now that it has run, let's go ahead to our resource ID, resource group. And once I go into the group, we should see our event grid. There you go, event grid topic. So now we already have an event grid system topic here. And it is, if you see, source type is Microsoft Resources subscriptions, or in this case, Azure subscriptions. If I added a subscription, in this case, event grid subscription, it does get a bit confusing. And let's just name it test sub 1. Hope that's available. That is available. Like I said, we could actually filter it down to multiple things. So we could say resource write, failure, action, success. There are multiple ways of figuring out what to filter it down to. We could also filter it further to what operations. So this can be data dot operation name. So let's say string is in. So we could say data dot operation name string is in websites, for example, or websites create, delete, or anything. So the way to figure that out is Microsoft documentation provides this full list of Azure resource provider operations, and all these operations we can filter it down to. So for example, the network delete, for example, so that can, one of the things we want to filter it down. So data operation name is in this. So if this is the operation, then the filter will be true, meaning that event will be triggered, or that event will be passed on to the handler. So let's delete this for the time being. Another exciting thing about here is, I'll just quickly open up how do we debug, because debugging event grid functions or event grid triggered functions is really exciting. So while Visual Studio is loading, let's quickly show the other bits here. One was that Microsoft does provide all these operations to filter. The other filtering we can also do here is by subject. So what subject means in this case is, again, we'll go into Microsoft documentation. I do have links to all these documents shared, so I'm sure you will have access to the slides. I'll give the slides to organizers, so you should be able to access it later on as well. So in subject, so this is the event JSON payload. So when an event is triggered, this is the JSON payload that comes with the event as an information as to what the event is about. So one of them is subject. So we could actually say when resource group is something, or it is about Microsoft storage, or if it is not about Microsoft storage. So all this filtering we can also do here. Anyway, we're not doing this filtering here. Let's go to Visual Studio. So about debugging, this is a default template of Azure Event Grid triggered Azure function. So if I just go ahead and start debugging, and it starts up, a little bit slow, or is it because it's starting the Azure emulator, storage emulator? So while it's starting up, let me show you Postman. So obviously, when Event Grid triggers your function, it is a HTTP request. That's exactly what we're going to do for using Postman. So if you see the URL here, this is same as what we will get here in the debug console. This comes up, and there, once we get the URL, we just go to runtime webhooks event grid and the function name here. And that way it will know which function to call. The bit to be careful about is in headers, we need to say that AEG event type is notification. It doesn't necessarily mean it is a notification, but it is for our own debugging. We need to set this. In body, this is where the JSON that we looked at in example event. So each the same JSON, we need to have it here, or at least the same format. And on the basis of the value we're getting, we can debug it. Just to note that different event sources, like this JSON is specific to Azure subscription, but other event sources will have different JSON. So you have to be careful about what you're using. So definitely go through the documentation when you are doing that. So going back to our event, our function. So debugging has started, and that's the event grid trigger function it has found. Let's go ahead to Postman and send a request. And like I said, it should trigger. There you go. It's hitting our breakpoint now. And if you see the event grid event now, and I'm just going to copy this out so that we can see. Okay, so just formatted it so that we can look at what's there. So if you see here, so this is essentially the same values as JSON that we have got here in the body of the Postman request. So that's one way of debugging. That is a case where you have a mocked up. Oh, I didn't want to stop debugging. Let's start debugging again. So that is when we wanted to have a mocked up request or mocked up event grid event. What if we really want a real event grid event to debug with? In that case, we have something called ngrok. So ngrok is a tool that will help redirect a request from one URL, which ngrok will give us now, to my localhost machine. So we need to copy the HTTPS URL, and if we go back to that event that we are creating, we just have to say, give me the webhook, and in the webhook we just paste that URL. Followed by the bit that we discussed earlier, the runtime webhook function 1, and confirm selection. So now when I create it, as soon as there is an event in my subscription, this breakpoint will be hit. And that could take a few minutes because event grid sometimes is slow. So let's see how long it takes. So you can see already that there has been an event which has been triggered. So that should hit my breakpoint very soon. Just checking my time quickly in case no, I think we're okay for time. Let's just quickly have a look. and the subscription here, even subscription I'm looking at here, that will soon show that it has picked up events. Sometimes these could take 5 minutes, 10 minutes to appear. That's just going through the demos. We just did the create topic and subscription. The debugging one is ongoing. And yeah, like you see, it has hit the breakpoint this time while we were puffing around. So let's see what's in this time. I'm going to copy it again, paste it back here, again, format it so that we can see what it came from. So like here you can see, should say, okay, resource URI. So in this JSON data that we got as a payload from Event Grid, the resource URI is this. And if you see, this is what we just did. We were working in the events subscription of test sub 1. And because that itself is an event in the Azure subscription, that triggered the event. And that's why this function has been called. Anyway, so that just roughly shows how to debug. And I hope that's useful because it's really exciting and it makes it so easy to debug these functions and write the functions. And believe it or not, once you are developing, you would want to debug it more and more often because it gets really complicated. I'm going to stop my ngrok because I don't want request redirected to my machine. So that's done. Next would be the demo of Azure Resource Graph. So the three technologies that we discussed a while ago were Azure Event Grid and next to Azure Resource Graph. So to understand what Azure Resource Graph does, let's just go into Azure Resource Graph. This is a simple a graph of resources in the subscription that I'm in, and with Azure Resource Graph Explorer, it's very easy to query and find out what resources are there, how they're behaving, and what are the properties mainly, not how they're behaving, essentially their properties. So if we didn't do that, let's go to resources. If I go to resources and run the query, it gives us so many resources, lots of resources here. Maybe we want to see what's the count. Then we can say resources, and this one here means pipe. So essentially the output of resources gets piped out to summarize count. Let's quickly get some water. So the resources quickly get the summarize the count. So the output of resources get piped with this method and then get the count. So if we run that bit, it gives us the total number of resources in the subscription. But we could do something even more exciting than that. And that is if we say resources pipe the output where the type is Microsoft Services sites, and we run the query. And we get the count. So we have 11 web apps in this case. So it can be function apps, it can be app services. And the thing to note about here is the equals to, well, essentially this one here, I can't select it. So this operator here essentially means do a case insensitive comparison. So essentially I could write small m, capital M here, and both of them will behave the same. So that's one way of getting the count, but we could also get the resources which are only web apps. In that case, we just do this, and there you go. We get only resources which are web apps. We can also do complex, a bit more complex actually, queries, where we want to say, get the resources, and then the resources output are just project in this case, same as SQL select. So you just show name, location, and type, and where type is again sites, and then we order by the name. If I trigger that, so then it again finds all of these resources. What I'm trying to explain here is that Azure Resource Graph here already gives us the ability to know about the resources in our subscription. Meaning, when we were discussing how our system or Azure function, when it's triggered by event grid, how will it know what are the IP ranges? These are here because when it finds an Azure function, it can just go into the properties. Oh, because we said project, it won't show us. We'll just take that out. And let's take this out. So essentially we're saying get us all the resources, which are web apps. And once we have got that, so let's just select one at random and we go into the properties. In the properties here, I'm going to copy this bit out again, just so that we can see. You see here, this is what we are after, the possible outbound IP ranges. And that's the whole list of IPs that the function could be sending request from. And these are the IPs that we will need to add in the network restriction rules so that the function, this function will be dependent on, can trigger. So we are putting the puzzles together. So hopefully you are still with me and you get what I'm talking about here. The technologies that we have been discussing till now obviously allow IPs. That's the system doing all the work, and that's an Azure function. And we have almost already covered that because we have explained the various bits out there. The next thing is, well, when to do it. Azure event grid is here. It will tell us that, okay, a new web app has been added, a new function has been added. So we know what happens and how to trigger it, or the or whenever an app service plan is scaled, then also event grid tells us that app service plan has been scaled, and that's when it tells the function to trigger. And once this function is triggered, it can go to Azure Resource Graph, which is what we looked at like a minute ago. And again, it makes our life much easier because we don't have to do any heavy work at all, because Resource Graph here is going to give us all the values, all the properties of the function. So we know which IPs we want to add. Finally, apply changes. Obviously, that is Azure. We just call Azure REST API and apply the changes. This makes it quite simple to understand what's going on here. But it does get quite complex. So where are these complexities coming from? First of all, so this whole discussion that we have has been based around Azure functions. But if you think about it, web apps are also, well, Azure functions are also websites or web apps, and the same way we also need to provide this same service for web apps or app services. So it could be simpler because we can use almost the same setup, except that in Resource Graph Explorer, we just say get us function apps and web apps as well, which will work exactly the same way. There is no issues whatsoever. The next bit is virtual network. What if some of them are VNet integrated? And that's a scenario we do have at my workplace in New Day, where some of the functions and web apps are VNet integrated, meaning they are restricted with whatever IPs they have, and some of them are not. In those cases, these network restriction rules need to allow list the VNet subnet ID. I'll get some more water as well quickly. So when a web app or a function app is VNet integrated, it needs to add its VNet subnet ID in the allow listing rule set. That's the only way it can then further go ahead and trigger other functions, or other function can trigger itself. And the other bit that we did not cover is when a resource is deleted, then what happens? So say in this system, a resource has been deleted, but when a resource is deleted, Azure Resource Graph cannot tell you what are the IPs. So you do not know what IPs to remove for a resource that has been deleted. It may not be a major issue, but the problem here is if the deleted rule is not removed, that IP you could be sharing with another consumer of Azure. It could be another company, another individual based somewhere else who would have that access to your function. It's one of the pieces of the puzzles that this person will need to access your function, but it's still one piece of the puzzle anyway. So we would not want to do that. But I'll probably touch on the solution to that as well. But when a resource is deleted, if you don't remove the resource, that leads to another issue here, which is this. The complexity here is that we have recently started seeing that the number of rules that we can apply in the access restrictions is limited to 512 rules, which has now been documented, but which is a major issue, because if we are automating the system and it's adding rules but not deleting them, meaning at some point we are going to hit that limit. And for that reason, we need to have a system so that we can remove those rules from already existing web apps and function apps. Even with the current existing situation, even if it did not remove rules and we have lots and lots of web apps and function apps, they will keep on adding rules, meaning they will eventually hit this limit. And while knowing all these things, let's look at the solution that has actually been implemented, or actually is being implemented. Part of it has already been done. So overall, the solution looks like this. It's a bit more complicated than what we had discussed before. There is a function. Well, all of them are in one function app. The main function is this one here, which takes in information as to what it needs to allow, and then creates a dependency graph and saves the graph in Cosmos DB. And after that, it then goes ahead and triggers a function to allow the rules that it has generated. And the reason it needs to keep things in Cosmos DB here is that whenever event grid triggers are scaled, or a function has been deleted, or a web app has been deleted, then they will read the dependency graph from Cosmos DB. So when it's scaled, reads it, generates new rules, applies those rules. But if, say, it's deleted, then it can go ahead and delete those items in the dependency graph and then generate new rules and overwrite it. In this case, it can overwrite. But if we do not want to overwrite, then we can actually keep a set of the rules in here and then make sure we remove those rules for the deleted resource. That's going well. And this is being implemented. I'm sorry, this is a bit complicated to go through, but I hope the introduction to various services makes it clear as to what we are trying to achieve and how. In conclusion, I think we will all agree that security is a complex affair, and we do have a lot of complexities in implementing a secured environment. On top of that, implementing principle of least privilege is even more complex. I hope you understand that, along with VNet integration, maybe Azure front door, applying network restrictions is just reducing the probability of somebody having access to Azure function, which is really good, but implementing it is a major overhead on your teams, because you do need to be very careful of how you're doing it so that you don't restrict your own services on that as well. And with the help of automation, hopefully you make sure that you're not making it a major overhead on the teams. And along with that, cloud security is a shared responsibility. I hope we all agree with that. Azure does make it much easier to deal with security, but it does leave a lot to the users. So we need to be extra careful while implementing security in our environment. I have a few extras here. First of all, Azure Event Grid, the debugging and Azure Event Grid subscription filtering, everything that I demoed are blog posts. The link also I've shared before. And now there are a few issues that we hit while working on this epic, if you like. Yeah. So those are on GitHub. So I've shared links to those issues here. So hopefully it saves you time if you do something similar or work with event grids, Azure Functions, and Cosmos DB in this case. Bit extra on access restrictions. So the rules that I was explaining in the beginning, and what is CID notation. If you're not in networking, it will probably be a bit difficult to understand, but once you get it, it's very easy to follow. So CID notations, so there's a blog post as well. You want to go ahead and check. Before we end, I would like to quickly thank the sponsors, Microsoft, and DevOps partner GitHub, along with the organizers, Amal and Ilyas, who have been helping me a lot with all this setup. Thank you to all of them. Thank you to the communities who are involved with Azure Conference, Azure Conference Dev Bangalore, Bengaluru, I'm sorry, and all the communities, so going to them. And finally, thank you to all of you for listening to this long talk. I'm Dushyant. Thank you very much. Any questions, please share them in the chat, and definitely reach back on Twitter. Thank you very much.